Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new concepts in mathematics. So, let us start our session today. So, let us start with a small recapitulation children. You can see the objects shown on your screen. Now, can you identify these objects, the shape which they have? Let us see. The first one is cone, that is right. What about the second one? Yes, it is a cuboid. The third one is a cube, whereas the fourth one is a sphere. And what about the last one children? Yes, it is a cylinder. So, children, in our today's session, we are going to learn about surface areas and volumes. By the end of this session, you will learn surface area of cuboid, volume of cuboid, surface area of cylinder and also the volume of a cylinder. So, the objects shown on your screen, a carton box, a rubric cube, these are the shapes of a cuboid and a cube. Now, let us consider this cuboid children. Now, let us cut this cuboid and see what happens. You are going to get a shape of this type. Okay, children, have a look at this book. Now, in this you can see the pages. Children, what is the shape of this page? Yes, it is a rectangle. Now, I am placing one page on other page like this. So, we have placed a large number of pages one above the other. Now, after placing this, now what is the shape of this book formed children? Yes, if you notice, this is exactly a cuboid shape. Okay, children. Now, let us label the length, breadth and height of this cuboid as L, B and H respectively. And you can notice it is divided into 6 regions children. It is divided into 6 regions children. This is the first area, second one, third one, fourth, fifth and sixth. And notice that they are all rectangles. So, if you cut open a cuboid, you got all these rectangles. Now, let us try to find the total surface area of this cuboid. So, it is given by area of the first rectangle plus second one, third one, fourth, fifth and sixth. So, adding all these areas, we get the total surface area of the cuboid. Now, children, if you notice the area of this first figure, it is a rectangle. Now, what is area of a rectangle children? That is right, it is length into breadth. So, here area of first one is L into B. Similarly, what about the second one children here? L into H, LH. So, similarly, we will write the areas of the remaining 6 rectangles. Okay, children. Now, if you notice, we have LB and LB. So, what do we get children? LB plus LB, 2LB, LH and HL both represent same. So, you can write 2HL, BH and BH, 2BH. So, what do you get children now? Yes, we get 2LB plus 2BH plus 2HL. And do you notice anything common in these 3 terms children? That is right. You can see 2 is common in all these 3 terms. Now, let us take that 2 as common factor. Now, what is left children? We got 2 into LB plus BH plus HL. Now, this is the formula to find the total surface area, or simply we write it as TSA of cuboid, which is 2 into LB plus BH plus HL square units. So, children, it is very important to write the units of this area also. Okay, children. Now, let us consider the lateral surface area of the cuboid. Now, what do you mean by lateral surface area? So, we are going to find only the sides, that is, we will remove the bottom as well as top portions, rest is all the lateral surface area. And in this case, the lateral surface area is given by areas of 2, 3, 4 and 6. Now, let us substitute the values of this. So, we got HL plus BH plus BH plus HL. Again HL and HL are added. So, you got how much children? Yes, 2HL. BH and BH, 2BH. Again here if you notice 2 is common, apart from that even H is also common. Now, let us take 2H common, we get into L plus B. Now, this is the formula, that is LSA of cuboid is 2H into L plus B square units. I hope you understood the concept of TSA and LSA of cuboid children. Now, let us find out the volume of the cuboid now. So, here the volume of the cuboid is nothing but the area of the rectangle into height. Now, why actually we are taking area of rectangle into height? We have seen already, children, the example of a notebook that we have piled one page above the other page. So, we got a cuboid shape, right. So, up to certain height h. So, that is why the area of the or the volume of the cuboid is the area of the rectangle multiplied by its height. Okay, children. Now, let us substitute the values of area of rectangle, that is L into B, and height we have assumed it as h. So, LB into h. So, what do you get, children? Yes, the volume of the cuboid is LBH cubic units. Let us see about a cube now. So, here, children, if you notice, a cube is nothing but a cuboid in which all the edges are of equal length. So, instead of L, B and H, we have A and A as its sides or edges. Now, in such cases, the LS of a cube is given by 4 A square square units, whereas the TSA of a cube is given by 6 A square square units, and the volume of cube is given by A cube cubic units. So, children, now we understood what is actually the total surface area, lateral surface area and volume of cuboid and cube. We will move on to our next figure, that is a cylinder. Let us find out the total surface area and volume of a cylinder. Children, can you identify the shapes of these objects shown on your screen? Yes, you are right. These all objects are in the shape of a cylinder. Now, in cylinder, you have a right cylinder or a right circular cylinder and an oblique cylinder. Now, let us see what are actually these two types. So, in right cylinder, if you notice, this is the radius, right, from center to any point on its circumference of this circular base or top, and here also distance between the center and any point on the circumference of this circular base. If you join this line segment, it is the radius. So, these two are radii, and this line is the line joining both the centers, and this line is perpendicular to the radius. Now, such type of cylinders are said to be right circular cylinder. So, what is a right circular cylinder? Yes, if the line segment joining the centers of base and top is perpendicular to the base, then it is called a right circular cylinder. Okay, children. Now, let us see what is this oblique cylinder. Now, here also, if you join the line joining the centers, you notice that here the angle formed is not 90 degrees. So, such cylinders are not right circular cylinders, or simply we call it as oblique cylinders. Okay, children. Now, let us consider the cylinder shown on your screen, children. Yes, here these circular portions both are called base. So, here we have at the bottom one and at the top one, and this region between these two we call it as the curved surface. Okay, children. But children, do you know how this cylinder is formed? Let us see. So, children, what do you notice in my hand? Yes, a circular disc, right? It is in the shape of a circle. Okay, forget about the hole which is presented in here in the CD. So, just we consider this as a circle. Okay. Now, if you are going to place a circle over another circle, like that I will go on keeping these circular discs one above the other like this. Okay, children. Now, if I completely place all these CDs one above the other, now children, notice what is obtained here. Can you guess the shape of this? Yes, if the height is still more, you can easily say that it represents what? What does it represent, children? Yes, it represents a cylinder. You can see it represents a cylinder which is formed by using what, children? Yes, simply a circular object or a simple circle. When placed one above the other, a large number of such circles, it forms a cylinder. Okay, children. Let us consider this cylinder. Now, the line joining the center and any point on this base. Okay, children. This we call it as radius. So, we have two bases. So, we have two radius, that is we call it as radii. Okay, children. So, radii is plural form of radius. then this is the line joining both the centers and which is perpendicular to both the radii. So, we call it as height. So, what is height, children? It is nothing but the perpendicular distance between the centers of two bases, that is called as height of the cylinder. Now, take a look at this cylinder, children. It is a hollow cylinder, right. Now, suppose if you are going to cut this cylinder, now what exactly you are going to get? Let us see. So, children, if you notice, if you cut open a cylinder, what did you get, children? Yes, you got a rectangle. That means a rectangular paper, when you fold in this manner, what is that you are going to get, children? Yes, you are going to get a cylinder. Okay, children. So, that means this is the curved surface area. Okay. Now, this curved surface area becomes what? A rectangle, which means the curved surface area of cylinder and the area of rectangle both must be same. Okay, children. So, that is what we are going to see in the same presentation, children. So, we are cutting a cylinder, and when you cut the cylinder, what is happening? We are getting a rectangle. So, the curved surface area of the cylinder and this area of rectangle both are equal. Okay, children. Now, let us find out the formula to find curved surface area of a cylinder. So, here if you consider this cylinder, the radius of the cylinder is r and the height of the cylinder is h. Now, this height h becomes the breadth for rectangle, and you are cutting this cylinder, right, and you got a rectangle. Now, this circular part will become the length of the rectangle. Now, this length of the circular part is nothing but what, children? Yes, that is circumference, which is 2 pi r. So, the length of the rectangle is 2 pi r and the breadth is h. So, what can we write, children? Yes, circumference of circle is 2 pi r and area of rectangle is given by length into breadth. So, which is the length can be written as what here? It is nothing but perimeter of base of the cylinder, okay, into height. Now, substituting the values, you got 2 pi r into h, curved surface area of cylinder is given by 2 pi r h square units. Now, let us find out the total surface area, children. Suppose if you are going to cut open the same cylinder which has top and bottom surfaces. We have seen previously a hollow without top and bottom. Now, if top and bottom is also there, if you cut open this, you are going to a rectangle with two circles. So, even we call this as net of a cylinder, children, which you have already learnt in previous class. Okay, children. So, here the total surface area of the cylinder is given by its curved surface area plus the top area and the bottom, that is the base area we call. Okay. Now, let us try to find the total surface area of cylinder, which is given by curved surface area plus area of base plus area of the top. Now, we have already seen the area of base or area of top, both are in circle shape, right. If you notice, both are circular in shape. So, what is the area of circle, children? Pi r square, and CSA we already got it as 2 pi r h. Now, let us substitute these values. So, 2 pi r h plus pi r square plus pi r square. So, pi r square plus pi r square will become 2 pi r square. Now, what is common, children, in these two terms? 2 pi and also 1 r. So, taking 2 pi r common, we get h plus r, or the same thing you can write it as 2 pi r into r plus h square units. This is the formula to find the total surface area of cylinder, that is 2 pi r into r plus h square units. Now, let us see how to find its volume. So, we have considered the same cylinder with radius r and height as h. Volume of cylinder is area of base into height. Why we have taken area of base into height, children? Because we have seen one circle over the other circle we are placing and we are getting a cylinder. So, area of base. So, your area of base is nothing but the circular part. So, area of circle is pi r square and height is h. So, when we multiply these two, you get pi r square h. Now, this is the formula to find the volume of a cylinder. Okay, children. So, children, till now we have seen the surface area of cuboid and its volume also. Not only that, even we calculated the formula to find the surface area and also the volume of a cylinder. Now, let us understand these concepts much more better way by doing some problems. Let us start with our first problem, children. An Olympic swimming pool is in the shape of a cuboid of dimensions 50 meters long and 25 meter wide. If it is 3 meter deep throughout, how many liters of water does it hold? Let us start with the solution. So, there is a swimming pool, right children, and what is given? The length of the swimming pool as 50 meters. And what about the breadth, children? Yes, 25 meters. And the depth, that is nothing but we can assume it as height of that say swimming pool, that is 3 meters. So, we need to find the volume of the cuboid, because it is in the shape of a cuboid now, swimming pool. So, what is the formula, children? Yes, 𝗹𝗵𝐻 cubic units. Now, let us substitute the values of L, B and H, children, that is 50 into 25 into 3. So, we get 3750. So, this is the volume of the swimming pool, but the water in the swimming pool is equal to the volume of the swimming pool. Here the volume of swimming pool is how much, children? 3750 cubic meters, but we know that 1 cubic meter is 1000 liters, children. So, what do we do? Yes, we need to multiply 3750 with 1000, and multiplying it we get 37,50,000 liters. So, this is the amount of water present or it can hold. Okay, children. Let us move on to our next problem. If the height of a cylindrical pipe is 20 meters and the radius is 10.5 meters, find its CSA, TSA and volume. Let us start with the solution. So, what is given, children? Yes, the radius of the cylinder is 10.5 meters and the height is 20 meters. So, CSA of a cylinder is given by 2 pi r h square units. Let us substitute the values of r and h. So, 2 into pi is 22 by 7 into 10.5 into 20. Now, 7 goes in 7 1 times and it goes in 10.5 1.5 times. Now, what is left, children? 2 into 22 into 1.5 into 20. On multiplying all these we get 1320 square meter. So, this is the CSA of cylinder. Let us find out the TSA of cylinder, which is 2 pi r into r plus h square units. Again we will substitute the values of r and h as shown. Again 7 goes 1 time and in 10.5 it goes 1.5 times. So, what is left, children? 2 into 22 into 1.5 into 30.5. Multiplying these we get 2013 square meters. Let us find out the volume of cylinder given by pi r square h cubic units. So, again we will substitute the values of r and h, and on cancelling with 7 we get 22 into 1.5 into 10.5 into 20. So, which is 6930 cubic meters. So, let us move on to our next problem, children. The diameter of a roller is 70 centimeters and its length is 100 centimeters. It takes 350 complete revolutions to roll once over the playground to level it. Find the area of the playground in square meters. Let us start with the solution. So, here is a roller and given its diameter 70 centimeters and length, that is 100 centimeters. So, since the diameter is 70, what is the radius, children? Half of it, that is 70 by 2, which is 35. The length of roller is already given as 100 centimeters, which we are going to consider it as height. Okay, children. Then area of the roller is nothing but the curved surface area of cylinder, and we know already the curved surface area of cylinder is 2 pi r h square units. Let us substitute these values. So, 2 into 22 by 7 into r is 35 into height, that is nothing but the length 100. So, on cancelling 7 with 1 time and 35 it goes 5 times. So, what do we get, children? Yes, we get 22,000 square centimeters. Now, this is nothing but if once the roller is rotated one revolution, that is nothing but the area of the roller. So, that we can write it as area of one revolution equal to 22,000 square centimeters. But here if you notice there are 350 complete revolutions, right. So, how much area it covers? Yes, 22,000 into 350. So, on multiplying them we get the number as shown but it is in square centimeters, right children, but we need to convert into square meters. So, what we are going to do? Yes, we are going to multiply by 1 by 100 into 1 by 100, or you will divide it by 100 into 100. Okay, children. So, on dividing this or on simplification, we get 770 square meters. Let us move on to our next problem, children. A rectangular sheet of aluminum foil is 44 centimeter long and 20 centimeter wide. A cylinder is made out of it by rolling the foil along the width. Find the volume of the cylinder. Let us start with the solution. So, there is a rectangular foil of length, how much children? 44 centimeters. And what is the width children? Yes, 20 centimeters. Now, this is folded to form a cylinder. So, that means height of the cylinder is nothing but 20 centimeters, because this breadth which is 20 centimeters, it is rolled along this side. So, the same height it has, that is cylinder, that is 20 centimeters. Now, since we are folding this, now this length of the rectangle becomes the circumference of this circle. Okay, children. So, what do we write? Height is 20 centimeters and length of the sheet is 44. So, circumference of the base is also equal to 44. So, what is the formula to find circumference of a circle, children? Yes, 2 pi r. That means 2 pi r is equal to 44 centimeters. Let us substitute the values now. So, 2 into 22 by 7 into r is 44. From this, r is equal to 44 into 7 by 22 into 1 by 2. So, 2 into 22 gives 44, and here we have 44. Both will get cancelled. We are left with only 7 into 1, which is 7. So, therefore, the radius of the cylinder is 7 centimeters. Now, you know the radius as well as the height, children. Now, what is the formula to find volume of cylinder, children? Yes, it is pi r square h cubic units. Now, let us substitute the values. Pi is 22 by 7, r is 7. So, r square 7 into 7 into height 20. So, here we will simplify. 7 goes one time and again here also it goes one time. What is left, children, now? Yes, 22 into 7 into 20, which gives 3080 cubic centimeters. So, children, we have seen the concepts of, say, cuboid, cube and also cylinder, and we have practiced some problems also, so that we are good at application part also. Now, before we end our session, let us quickly recap what we have learnt. The figures which have length, breadth and height are called as 3-dimensional figures or 3D objects or solid figures. Cuboids and cubes are regular prisms having 6 faces, and of which 4 are lateral surfaces or lateral faces and has base and a top. Lateral surface area of cuboid is 2h into L plus b square units, whereas the total surface area is 2 into Lb plus Bh plus Hl square units. The volume of the cuboid is Lbh cubic units. Lateral surface area of cube is 4s square square units, where s is the side or the edge of the cube. Also, total surface area of cube is 6s square square unit, and volume of cube is s cube cubic units. A cylinder is a solid having 2 circular ends with a curved surface area. If the line segment joining the centers of base and top is perpendicular to the base, then it is called a right circular cylinder. The curved surface area of a cylinder is given by 2 pi r h square units. The total surface area of a cylinder is given by 2 pi r into r plus h square units. The volume of a cylinder is given by pi r square h cubic units. So, children, before we end our session, I would like to give you some problems to work it in your home and show to your teacher. Let us see those problems. The volume of a cuboid is 1800 centimeter cube. The length is 15 centimeters and breadth is 10 centimeters. Find its height. The curved surface area of cylinder is 1320 centimeter square and its volume is 9240 centimeter cube. Find its height. A rectangular sheet of paper 22 centimeter into 10 centimeter is rolled along the length to form a cylinder. Assuming that the cylinder is solid, find its radius and the total surface area. The total surface area of a cube is 3750 square centimeters. Find its volume. So, children, with this we have come to the end of our digital class. I hope you have understood the concepts and also the application part of it. So, we will meet in the next digital class. Until then, goodbye and take care.